Good morning, everyone. We are the Lego Ultimates, and today we are very excited to present about our brand new project, which is the desk cleaner board. But before I begin, let me introduce my teammates, which me, Parin, the leader of this group, and my members Tanish, Kartigan, Shashivan, and Hari. Many schools, many classrooms, the students leave their desk messy and unclean, and it often affects hygiene and ability for the students to focus in lessons. And on top of that, we realize that manually cleaning desks takes time and is often neglected too. And to find a solution to this problem, we decided to get together and do this robot. And now let me pass it on to my teammate Harish. Thank you.
After some preliminary discussion, we landed on an idea which is a robot that cleans desks, reduces effort required by teachers and students, and makes classroom cleaner and more comfortable. At first, we had many ideas how the robot should look and work, but our teacher guided us to simplify the design and work more on the main function, which is cleaning effectively. This helped us to stay focused and move forward. We brainstormed some ideas, selected materials, and began working on the development of the robot. This meant sketching out the structure, deciding the cleaning mechanism would be attached and prepared for the assembly and coding process. We aligned our project with the United Nations Sustainable Development Goals, especially Goal 4, Quality Education, by promoting hands-on STEM learning. Goal 9, Industry, Innovation and Infrastructure, by encouraging creative through robotics. Goal 12, Responsible Consumption and Production, by helping maintain cleanliness and reduce waste.
I'm Tanish. Our robot is been mainly using Lego Spike education blocks, which makes it easy to assemble, modify and also improve. It moves using the wheels powered by a motor, allowing it to travel smoothly across the desk surface. To clean the desk, we attach the sponge underneath the robot. As it moves, the sponge wipes away the dust and also the dirt. We also include a collision sensor so the robot can detect obstacles and avoid crashing. We also included a color sensor as a creative workaround for unavailability of parts, specifically the distance sensor at the bottom for edge detection. The robot is controlled through a Lego Spy hub, which acts as a main control center and a brain for the robot. This hub connects to motors, sensors, batteries, and allows us to program the robot using the coding platform of our choice, which is Scratch. Thank you. Now I'll pass on the presentation to Kartikeyan.
One of the biggest challenges we faced was coding the robot. At first we tried using Python, hoping it would give us more control, but soon we realized that it was too complex for our setup. The commands were harder to link with the sensors, and even small errors caused the robot to stop moving. It felt frustrating at times, but it taught us how important it is to choose the right tools for the job. After several attempts, we decided to switch to Scratch, which turned out to be much simpler and easier to manage. With Scratch, we could visualize the blocks, test each movement, and fix problems faster. That change made coding more enjoyable and easier, and also helped us focus on improving the robot's performance instead of debugging endlessly. We also faced difficulties with the building process. Sometimes the robot will topple over because it was too bottom heavy, and the sponge kept falling off no matter how we tried to attach it. Each time it failed, we went back to the drawing board, adjusting the design, testing again, and learning from every mistake. Through repeated testing, teamwork, and trial error, we gradually improved the design. We found a way to fit the sponge securely and tightly. We also stabilized the movement and refined the coding logic so everything works smoothly together. Each stage brought new problems, but every problem pushed us to test, adjust, and improve. In the end, we overcame all the setbacks and ended up with a robot that works reliably and shows how persistence and creativity can turn challenges into success.
Hi, I'm Shashivan. Let me present our conclusion. As we conclude our presentation, we want to highlight why this project truly matters. A desk cleaner is more than just a robot. It's a practical solution to a real-life problem in schools. By keeping desks cleaner, it's improved hygiene, comfort, and focus for student and teacher. It also saves time and effort, making classroom more pleasant and efficient. Beyond the cleaning itself, This project gave us valuable experience. We learned how to apply coding and robotics in a real life context, how to solve problems when things didn't go as planned, and how to collaborate effectively as a team. Each challenge taught us persistence and creativity. Most importantly, the desk cleaner shows how technology can be used to solve everyday problems. It connects directly to STEM education, encouraging innovation and inspiring students to see robotics as something useful and exciting. Looking ahead, we see opportunities to improve, like upgrading the sensor for better navigation or enhancing the movement of robot. So far, we are proud of what we have achieved. Thank you for listening, and we hope you enjoy learning about the Lego Ultimate creation, which is the desk cleaner.